So we are back with another practice question set. So hope you have tried the homogeneous equations practice question set in the article, and here in this video I am going to discuss how to solve them. So when solving this type of equation, we need to use the substitution y equals vx, or else v equals y by x. So by differentiating this, we get dy by dx equals v plus x dv by dx. So in this equation, we have x squared plus y squared root dx equals x dy minus y dx. So we need to convert this into a form like dy by dx equals something. So to convert this, we can divide the whole equation by dx. So then we get we can substitute we can subject dy by dx in the left hand side of the equation. Then we get dy by dx equals to x squared plus y squared plus y divided by x. So then we can do the substitution y equals vx here. Dy by dx equals, so we can divide the two terms in the numerator by x. So then we get y by x whole thing squared square root plus y by x. So we can substitute v for this y by x term, and for the dy by dx in the equation we can substitute v plus x dv by dx. So by substituting that, x v plus x dv by dx equals 1 plus v squared square root plus v. So for this we get cancel out, and then we get dv by dx equals x dv by dx equals 1 plus v squared square root. So making this into separable equation, we can take the x term to one side. So 1 over x dx equals 1 over 1 plus v squared square root dv. And then we can do the integration since we have converted this into separable equation. So 1 over x is ln x, integration of 1 over x is ln x, and then for this ln 1 plus v squared square root 1 minus square root. And so here for this type of integral we have to do it like this: v plus v squared minus 1 square root plus c. So by back substituting for v, we get ln y by x plus y squared x squared minus 1 plus c. So here c is the integration constant. So we can keep the answer like this for this first question. Basically we need to remember is that we need to put this substitution when solving. Okay, then moving on to the second equation, we have dy by dx equals 3xy divided by x squared plus y squared. So for this one also, so we have dy by dx being subjected, and then we need to use the substitution y equal vx. Dy by dx equals v plus x dv by dx. And here we need to substitute for x and y by v. So dividing both numerator and the denominator by x squared, we get 3 y by x 1 plus y by x whole thing squared, and then we get 3v over 1 plus v squared. And for this dy by dx, we are substituting this one: v plus x dv by dx equals 3v 1 plus v squared. And then we have x dv by dx equals, taking this v to the other side, 3v minus v cube 1 plus v squared. So simplifying this, we get v2 minus v squared over 1 plus v squared. So making this into separable equation, we get 1 over x dx equals 1 plus v squared v2 minus v squared dv. So we can integrate like this. The integration of 1 over x is simple, ln x equals, so how to do this integration of this? We can use partial fractions for that part. So how do we do partial fractions is 1 plus v squared to 2 minus v squared. So we can do it like this: a over v plus b over, so we can further simplify this part like 2 root 2 minus v and root 2 plus v. So okay, then simplifying, we get 1 plus v squared equals a 2 minus v squared plus bv root 2 plus v, and then c v root 2 minus v. So simplifying this, we get so comparing the coefficient, so when we compare the coefficient of v squared, we get minus a plus b minus c, and then comparing the coefficients of, when comparing the coefficients of v squared, so when we compare the coefficients of v to the power 1, 0 equals root 2b plus root 2c. So basically b plus c equals 0, so b plus c equals 0, and then we can get b equals minus c likewise. So comparing the coefficients of v to the power 0, 1 equals 2a, so we get a equals half, and then we get using this first equation, we get 1 equals minus half. So here b minus c is b minus c, so here we can substitute for b minus c, and then we get 2z equals minus half minus 1, which is minus 3 over 2. So c we get minus 3 over 4, and also since b is equals to minus c, we get b equals 3 over 4. So by substituting here, we get the integral as integral of a over v. So we found a is half, so a over v dv, plus b we found 3 over 4, so integral 3 over 4 root 2 minus v dv, plus, and then c we found as minus 3 over 4, so minus 3 over 4 root 2 plus v dv. And then we get the solution like this by solving 1 over 2v, the integral of 1 over 2v, we get ln v by 2, plus, and similar thing happens here, ln root 2 minus v divided by minus 1, and then we get minus 3 over 4 ln root 2 plus v plus c, where c is the integration constant. And then further simplifying and back substituting for v, we get half ln y by x minus 3 over 4 ln root 2 minus y by x minus 3 over 4 ln root 2 plus y by x plus c. So even we can combine these two by so we can do it like this. We can keep the answer like this since it seems complex when we solve for further, but we can make the common denominator x here as well. So this can be written as the answer for this equation. So moving on to the third part of the question set, we have another equation, dy by dx equals x minus y divided by x plus y. So for this one also we need to use a substitution. Y equal vx, dy by dx equals v plus x dv by dx. So when we substitute dy by dx equals, so dividing this numerator and denominator by x, we get 1 over 1 minus y over x, and then 1 plus y over x. So substituting for y over x, 1 minus v divided by 1 plus v, and then substituting for dy by dx, v plus x dv by dx equals 1 minus v, 1 plus v. And then substituting for, so we got this by substituting for this, and so which is the major part in this homogeneous equation solving method. And then we get by simplifying, we take this v to the other side of the equation, and then we can get 1 minus v squared 1 plus v. Here we get 1 minus 2v minus v squared 1 plus v. So by using the separable equation method, so we can separate the variables. 1 over x dx equals 1 plus v 1 minus 2v minus v squared dv. So we can do the integration here as well. So to solve this again, I think we need to use partial fractions or any other solving method. Yes, so for this one, so what we do is we can create the differentiation of the denominator in the numerator. So how about that? So here we get ln x, obviously ln x equals, so for this one we can make the differentiation of, so the differentiation of this one is, we can write like so. The differentiation of 1 minus 2v minus v squared is minus 2v. So how about making minus 2v in the numerator and keeping the denominator as it is? So what is the change that we have made for this to get this is, just we have multiplied the numerator by minus 2. So to avoid that change that we have done to the numerator, so we can simply divide by minus 2, simply divided by minus 2. So for this one there is a method like the integral of f dash x over fx dx is ln fx. So we are using that one here. So then we get ln x equals minus half ln 1 minus 2v minus v squared plus c. So then back substituting for v, we get minus half ln 1 minus 2y by x minus y by x whole thing squared plus c. So you can keep the answer like this. So we have done 3 questions in the practice question set of the article. So hope you are getting a clear idea of how to solve these type of homogeneous equations using the popular substitution. Y equals vx, then dy by dx equals v plus x dv by dx. So stay tuned for more discussions like this. Thank you.